know the secret to why life can feel so random? Okay, I'll tell you. It's Brownian motion.
Hold up! Do you mean Brownian motion?
No, I mean Brownian motion.
Brownian motion is the random movement of particles in a gas or liquid that is caused by the unequal bombardment of other molecules in the medium. It was first discovered by Robert Brown in 1827, who noticed that a pollen grain suspended in water was moving in a random pattern. Later, in 1905, Albert Einstein derived a quantitative expression for Brownian motion using the kinetic theory of molecules, which we'll get to in just a moment.
Here's how Brownian motion works. Let's say that the ping pong balls inside this container represent particles of liquid. According to the kinetic theory of molecules, atoms are constantly in motion, which leads to random collisions, like so.
When you have another larger particle in the liquid, like this red ball, you can see that it jiggles randomly due to the other ping pong balls. Therefore, the red ball represents a particle that is undergoing Brownian motion. Using statistical analysis, Einstein derived that the displacement x, the shortest distance from the initial to final position of a Brownian particle, is equal to the square root of 2 dt, where t is time and d is the diffusion constant that is determined by the Stokes-Einstein formula, and depends primarily on viscosity and temperature of a fluid. A greater diffusion constant means that the displacement of a Brownian particle will be greater as well. So we can see that diffusion is a macroscopic manifestation of Brownian motion. Here we have boiled and regular tap water. We can see the diffusion constant at work using dye. The dye spreads faster in boiled water than the regular water, since a greater amount of random collisions occur due to a higher temperature, forcing the dye to move in a random path that spreads out faster. There are two types of Brownian motion, unbiased and biased random walks. Let's think of the Brownian particle as a tourist who's lost in a big city. They have absolutely no idea where they should go, so the probability of them moving in any direction is equal since they are so lost. This is called an unbiased random walk. However, most cases of Brownian motion are biased random walks, meaning that they have a probability to travel in a preferred direction. This bias is mainly due to the presence of a diffusion coefficient. It's like handing a map to a tourist. They finally gain a sense of direction and have a higher probability of reaching the right destination. An example of biased Brownian motion is seen in the travel of neurotransmitters throughout neurons, as well as gel electrophoresis, because the particles have an affinity for a certain direction.
The best part about Brownian motion is that it's all around us. From explaining how molecules move within a cell, to how robots navigate on random terrain on Mars, to even predicting stock prices in finance, Brownian motion is so applicable to our lives. It's amazing how this very physics concept has helped humanity deal with seemingly random situations. All thanks to Brownian motion.